Well, hello everyone. Today, my name is Basil Stambekov, and on this presentation today, I am going to talk about El Gamal crypto system, one of the important public key exchanges in cryptography. All right, let's get into it. Uh, Let me actually talk about a little history of cryptography itself. As we all know, I think it was in the first class of our class, the professor told us in cryptography, basically, it divides by main three blocks, which is the first one is being like a symmetric ciphers. Basically, what it means is like in symmetric ciphers, there's only one and then only one key which encrypts the text, and then the same key used for decryption itself. Then symmetric ciphers have been in a long time in our lives. Even back in the days, the a lot of warriors used the basic symmetric ciphers, and then in 20th centuries there's another other cipher came up, which is called like asymmetric ciphers. Uh, what it means is basically asymmetric cipher is a cipher where you basically will have two keys. One is being a public key and another is being a private key. With the private key, you basically encrypt your message that you want to encrypt, and then with the public key, it can be like like everyone can know your public key, like if you want them to know, but they will need a private key to like decrypt the message that you encrypted. So basically, it has like a two keys, which is one is private and then one is public key. And another cipher is protocols, and then we're not gonna touch that protocol thing today. So basically, El Gamal crypto system is in the layer two, which is in asymmetric key encryption algorithm. So which is it's like basically has like two keys, as I've explained. One is private and one is public key. So 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 the El Gamal encryption system is an as I've told you, like a asymmetric key encryption algorithm, and then it's basically based on a Diffie-Hellman key exchange. Um, and later I'm going to explain the Diffie-Hellman key exchange once again, but I remember that we already covered the Diffie-Hellman key exchange a little bit in the class, but I'm gonna make sure to explain a little bit Diffie-Hellman so that we have more idea of the El Gamal crypto system and how it is based on the Diffie-Hellman key exchange. Diffie-Hellman key exchange was found by an Egyptian. His name was I think it was like Tahir El Gamal, and it was discovered in 1985. Basically, all right. All right. Let me talk about a little bit Diffie-Hellman. How does it work? As we all know, we've been introduced Alice and Bob. And the Alice, two people, which they wanna they wanna exchange messages through a encryption, so that no one in the middle cannot read the message. So how do they do that? For in Diffie-Hellman key exchange, public key exchange, and basically it works like we have an Alice and we have an Bob, right? And then let's say in Alice and Bob, I'm just gonna explain it in the colors, not in the mathematics. I'll explain the El Gamal in mathematics, so but I'm gonna just try to explain in color so you will get a more idea of how does it work visually. All right. So we have basically two people, Alice and Bob, and they want to exchange a key between them, right? And then let's say like what they need is a one common paint, which is it's being a yellow in here. So they both will have yellow colors, and then each Alice and Bob will have the Alice's their own separate like a color. Let's say Alice have this orange color and Bob has this green color. So basically what it means is like these yellow colors is illustrates the public key which Alice and Bob both have, and then the orange and the green colors illustrates the private key which they have within each other. Like they don't even know each other's private key. All right. So next step is basically will they will mix this, let's say like Alice will mix yellow color with the orange, and then Bob will mix a yellow with the green color, and what they will get is this two kind of colors. The Bob got a blue color, and then Alice got a kind of like a brown orange. And then once they have it, right, once they have it, and like don't forget the Alice and Bob still have their private colors, which is like orange and green in separate. They know it, and then once they have this mixture of colors, the Alice is gonna send his her color to the Bob, and Bob is gonna do the same thing and then send his color to Alice. And once the Alice and Bob has their mixed color, um, they will mix once again with their own private color. Like basically, Alice will mix the blue color with the orange, and then Bob is gonna mix the his private color, the green color, with the brown kind of color. Once they will do it, they will have the same color. Basically, they have the same color because they've already like mixed all the colors, and then they will have a basically same color, which means they will have the same key for decryption. And then once they have this key, then they could basically decrypt a message. All right. Once we understood Diffie-Hellman how it works, and let's move on to El-Gamal, public key exchange. El-Gamal encryption. So before like understanding El-Gamal encryption, how does it work, the description of it, let me talk about this a little bit. So before like a key exchange, before like exchanging the encryption messages between Alice and Bob, before they do that, they will need they will need to generate their own keys, like and then they have to choose a large prime number, let's say it's p, right, and then they have to choose a primitive value, let's say it's like a, and it has modulo n. So, and then they have to choose the random x such that x is even bigger or equal to the 2, or like less than or equal to n minus 2. All right, let's get into like how actually El-Gamal encryption system works. So basically, let's say instead of like I just put it like instead of Alice and Bob, we have user A and user B, right? They're like private, and then no one can see their own keys, public or like private keys. Basically, in the middle, what happens is like as I told you, like they have like a primitive like a, and then they need a large prime number p. Once they have those two keys, let's say that user A user A basically grabs that A and then chooses one of the K, like let's say one, like any number, it has to be in that chosen number, and then it will basically A exponent of K will in a module of that prime, and basically she's gonna send that to the user B. Same thing is gonna go for the user B, and he's gonna send the same thing to the user A. Once they have it, basically what they need is user A is gonna like take that formula and expand it to his private key, which he used before, to the K, and then do the same thing as modulo P, as you can see in here. Once the user B gets A exponent of K mod P, he's gonna do the same thing. He's gonna raise A to the K to his own key, which is X. AK to the X, and then mod P. So basically, if you can see in here, like you basically have the same, like in mathematician, right? Like the order doesn't matter. If it's multiplication or like addition, the order doesn't matter. So x raised to the k, or like k raised to the x mod of p, is the same thing. Basically, they will both have the same keys. And once they have the same key, the user A is gonna like encrypt his message, right? Encrypt his message, multiply it by k, which is this formula A to the x raised to the k mod of p, and he will take the mod of p of those formula, and he will send it to the user B. Once the user B will get that ciphertext, he's gonna decrypt it using the same key as he got it before. Remember how I explained in the Diffie-Hellman key exchange how they have like a private yellow colors, and then ones have the private key and then the other has his own private key, but once they mix the colors, they will end it up with the same brown color. Basically the same thing happening in here in El Gamal, except the Diffie-Hellman is used only for like a key public key exchanges. There's like a, they don't actually like add the message and encrypt it. They will just use it for the public key exchange. But in Elgamal, you can basically encrypt. So you can basically exchange a public key. Once the public key is exchanged, they can add the message and encrypt and then send it to the user B. Basically, user B is getting the same formula, which is like a brown color in Diffie-Hellman, and then using that color, the same formula, he's gonna decrypt the message, and he will get a deciphered, decrypted ciphered message, basically. All right, and then one more thing is like I want to mention is Elgamal is it is not a CCA secure, but it is a CPA secure. What it means is basically Elgamal is like not ciphertext, like for ciphertext, for cipher attack is not secure. Basically, the middleman in the attacker, the middleman in the middle can, if he wants to, like if he's like an active attacker, then he can actually break the encrypted ciphertext, and then he can get it, or like he can like change the ciphertext before the user B gets it. To like if you want to be your message not to be changed or like not to be decrypted, then you must like a hash and then mac it the message, so that the middleman, the middle attacker, the active middle attacker cannot change it. So all right, that would be it for me for presentation. Thank you for listening.